Let's start with the basics. What exactly is a computer network? At its core, a computer network is a collection of devices like computers, printers, or smartphones connected together so they can share information and resources. These devices, often called nodes, communicate through various types of links, which could be physical cables or wireless signals. Networks aren't just about connecting computers. They allow us to share files, use shared printers, and even make phone calls over the internet. The most famous example, the internet itself, a massive network of networks. It's important to note the difference between a computer network and a distributed system. While a network connects devices, a distributed system makes those devices work together as if they were a single system, often using special software called middleware. Understanding these basics sets the stage for exploring how networks are used in business, at home, and on the go. Now let's dive into the different types and shapes of networks. Networks can be classified by size, like LAN's local area networks for small areas, MAN's metropolitan area networks for cities, and WAN's wide area networks that span countries or even continents. But networks also have different physical layouts known as topologies. The mesh topology connects every device to every other device, offering high reliability but at a higher cost. Star topology uses a central hub, making management easier but risking total failure if the hub goes down. Bus topology connects all devices in a line, which is simple but not ideal for large networks. Ring topology forms a circle, allowing data to travel in one or both directions, but a single break can affect the whole network. Hybrid topologies combine these shapes for flexibility. Each type and topology has its own advantages and disadvantages, making them suitable for different scenarios from small offices to global enterprises. How do networks actually move data? That's where transmission media and switching come in. Transmission media are the physical or wireless paths that data travels, like twisted pair cables, coaxial cables, fiber optic cables, or even radio waves. Each has its own strengths. Fiber optic cables offer high speed and resistance to interference, while wireless media like radio and microwaves enable mobility. But connecting every device directly isn't practical for large networks. That's why switching is used. There are three main types: circuit switching, dedicated paths like traditional phone calls; packet switching, data split into packets as in the internet; and virtual circuit switching, a mix of both. Packet switching used by the internet is efficient and flexible, allowing data to find the best path to its destination. Understanding these concepts helps explain how information gets from point A to point B, whether you're sending an email across the office or streaming a video from another continent. Organize all these networking functions. Engineers use models like OSI and TCP/IP. The OSI model has 7 layers, from the physical layer, cables and signals, up to the application layer, what users interact with. Each layer has a specific role, like routing data, ensuring reliable delivery, or managing sessions. The TCP/IP model, which powers the internet, is simpler with 4 layers but covers similar ground. These models help standardize how devices communicate, making it possible for different hardware and software to work together. For example, when you send an email, your message passes through these layers, getting packaged, addressed, transmitted, and finally delivered to the recipient. Understanding these models is key for anyone studying computer networks, as they form the backbone of how modern digital communication works.